Welcome back to the lab, and today we have what looks like an entire mess of hoses, and well, we used almost all of them for this experiment, and we only have one cylinder. This is a regenerative circuit. We have a couple of things in here that are mentioned in the lab. First of all, we have a flow gauge. That's it right there. We also have a pressure reduction valve, and we have a flow controller in here. It's kind of hard to see because of all of the extra equipment in this particular lab. This is the return manifold, and this is because we have a closed center directional control valve. And regenerative circuit requires a flow through from the A to the B in terms of the directional control valve, and we don't have one of those, so I've had to make do with basically simulating that with this extra manifold here and a couple of extra hoses. What we have too is a couple of pressure gauges here, and I'm just going to show you the increase in the speed as we turn this on before we add a load. Okay, now you'll notice a curious thing. We have full system pressure, 3,500 on this particular conductor right here, because this is seeing fluid directly from the pump, because it bypasses, if we take a look there, the return side bypasses and goes directly from the pump side. Even though there's no flow, because it's not doing anything, there is indeed pressure. So, let's take it for a drive and see what happens. Notice that in this case, I've got the A point. I used the B port as opposed to the A port in this experiment just because it was closer. And you'll see that I do have a pressure applied here, which is a curious thing because the valve hasn't been stroked yet. So let's see what happens as I extend it and retract it. Now you'll notice if I reduce the restriction, and I'll take the restriction all the way off at first. Okay, so we're totally reducing the restriction on that flow control valve there. You can kind of see it. I mixed all of the stuff. Now watch the flow valve. And you see that in the regenerative on the backstroke, I'm getting more flow out of my pump than I am on the front stroke. The reason for that is because on the front stroke, or the extension, the pump doesn't have to provide all of the fluid. It only has to provide the amount of fluid of the cap area minus the rod. So actually the flow has been supplemented. So, and I can slow that down for you, and we'll just see what happens there. I'll just slow that down. And you'll see again that I'm getting more flow in the retraction than I am in the extension. And that makes sense because the fluid required to fill the cap end, part of it is coming from the rod end. So that makes it less fluid has to come out of the pump. Another curious thing is this is under pressure. It's under system pressure in the return. So this is being held here by system pressure, which is unusual in most cases. Now, as you can see here, if I partially stroke the valve, let's put it to halfway, I have pressure on this side balancing the pressure on that side. So if I were to take, and this is curious, I'll have to take a picture of this and do the math on it, but my speculation is that this times the difference in the area will equal to this gauge, which is kind of neat. So you can see here that speed has definitely been increased from previous experiments. And let's crank this down a fair bit on that flow control valve here, almost turning it right off. Let's see what happens now. We do slow it down, but it is faster on one stroke than it is on the other. So just to accentuate that a bit more, on the outward stroke versus the inward stroke. And you'll see that it takes a fair amount of time for an inward stroke, but less time for an outward stroke. And that makes sense, okay? But again, you've got the pressure building up to complete system pressure on the retraction. Now, if it's a 2-to-1 cylinder, you're going to be able to get the same speed and the same amount of force in both directions on a 2-to-1 cylinder. This isn't a 2-to-1 cylinder. This is a 0.6. It's kind of close, but not really. And you'll see that the pressure will equalize. And the backward stroke. Now, pressure is come up on the backward stroke because it's being fed from the pump. Now, interestingly enough, if this was a regular closed center directional control valve, there would be no flow. There would be a static pressure, but the pressures would be equal. But as you can see here that the pressure rises, and get a good look at that. So as I retract it, there's no pressure, and the pressure builds only after the load is resisted because it's fully retracted. On the extension stroke, the pressure will rise to system pressure after everything has been satisfied. So I'll just stroke it halfway, and you can see that it's about halfway, and you'll see that the pressure on the rod side looks to be about ratio higher than pressure on the cap side, which is very useful. And that's with a fairly decent restriction on there. Now again, with a fairly decent restriction on there, let's take a look at the flow carefully. If I can close in on that flow valve. And it's kind of hard to see. Such a small cylinder, such a small load, it's really tough to get that example of more flow coming from the pump in the backstroke than the extension, but let's see what we get here. So this is extension, and it's not quite 1, and it happens very fast. So we're getting about 1 gallon per minute. Let's see if we can't get the other scale here. So this is my liters per minute. Might be easier to see. And we're getting about 4 liters per minute on my outstroke, and on my backstroke, I'm getting more than that. I'm getting close to 6. And again, the flow is ratio different between one and the other due to the fact that the annular area is adding directly back to the supply. Now, let's just make one simple change here. And that's going to be taking, let's see where I am here. This one of them that goes back to this one to here, this one to here. Okay, this one belongs here. I'm just going to take this directly back to the tank now, as it says in the lab, and we'll see what that does for us. And of course it won't retract because, oh, I know what I did wrong. 1 second. I don't take it directly back to the tank. Silly man. I take it back to the B port so it can return to the tank like it's supposed to. And I will just adjust the camera there a little bit. Stop doing this without an assistant. Okay. Now let's see what happens. Boom. Very fast and a very predictable, same speed out as in. Let's play our flow restriction now, just to slow it down a little bit to see if we get a speed change. When it's cranked all the way in, I'll crank it in a bit and out about a turn. And yes, it does slow the cylinder down. But curiously, notice that it only slows it down on the extension stroke because of the bypass valve and the fact that it has an unfettered return path to the tank without going through that restriction. So really all we can slow down is the extension stroke. And still it's kind of ratio. Now what's our flow rate like? Well, let's take our flow rate on, if I go backwards, I'm getting about 2 liters per minute. As I go forwards, I'm getting 2 liters per minute. And that makes sense because I don't have a regenerative circuit right now. Okay, let's do one more thing here. I'm going to attach our load. This is our load for this, for the final step in this procedure. Oops, I better retract my cylinder. Retracted. Okay. Now we'll shut off the power when you're playing with this stuff, because it does bite. Alright, now I'll just screw this load on here and make sure that I get 5 threads in there so it doesn't come shooting across the room. And I'll get another turn out of it. Okay, well that's not too bad. We can definitely see the load there. So let's see what the load is like on the spring. And I get about, well, 300 and change pounds of force on that. And let's see what happens when I put it in regenerative mode. So regenerative mode again. I'm going to move this from B. Make sure I unload my circuit. And I'm going to put it back into my manifold here. As you can see, my manifold through alpha hoses. Yes, I know it's a little bit much, but let's see what we can do here. And that's clicked in there nice and tightly. Let's see what we get out of this now. And we're not developing as much force. Even though we're getting as much from our system, we're not putting as much force onto the cylinder. The reason for that is because the force is reduced because I'm actually adding fluid charged back into the system. So the regenerative circuit doesn't help you much on force per se, but sure does help in speed of reaction. And that's the advantage of it. So you'll notice in the experimenter, in the notes package, there is a different valve used in a regenerative circuit. Not like this one. It is actually a 4-position valve where it has the regenerative loop from A to B in one of your output cycles. And the reason for that is to give you that regeneration. That's great if I'm using a circuit that is required to go to position very quickly and then slow down and do its job. Let's say I'm bending metal would be a good example of that. Okay, so that's regenerative circuits, and that is how they work. And as you can see, that there's quite a bit that goes into them compared to some of the other labs we've had. We didn't have this many hoses and manifolds with 2 cylinders, as opposed to 1 cylinder here just doing one job. Okay, and we'll see you next time. Thanks for coming out.